So, how are the frozen water crystals photographed? We begin by collecting a sample of the water that we want to observe. Here, our researcher is at Shiraito no Taki Falls, a well-known spring on the slopes of Mount Fuji. The tremendous amount of water that precipitates on Mount Fuji travels through the mountain as groundwater. 20 years later, it pours out as spring water here at the Shiraito no Taki Falls, where the water flow amounts to more than 100,000 tons per day. Water gushing forth relentlessly from the cliff. In search of water, our researcher is approaching an area just below the fall. He is filling the container with fresh water. He brings the water back to the institute as specimen. First, he taps the bottom of the container to activate the water. Then, he squirts 1 milliliter of water onto each petri dish. In order to obtain a more accurate crystallization trend, we create 50 frozen samples of every water specimen. The petri dishes are placed inside a freezer in the laboratory and frozen at -25 degrees centigrade. The crystals are then examined inside our laboratory, where the temperature remains at a constant -5 degrees centigrade. 3 hours later, we examine the tip of each ice block by illuminating it under a microscope. The crystals start to grow and expand as the temperature of the ice tip rises under the microscope. Usually, however, of the 50 ice blocks that we have to work with, only a few reveal their beautiful hexagonal crystals on camera. What kind of crystal will the water from Shiraito no Taki Falls show us? A beautiful hexagonal crystal with delicate trimmings growing slowly from the 6 points of the hexagonal core. In one quick moment, our researcher identifies a sparkle and photographs it, all within minutes, while the crystal continues to grow and expand before it returns to its liquid state. A lateral view of the ice block reveals a protrusion at the top. That is because rather than growing two-dimensionally, water crystals grow three-dimensionally from the center of the core out.